ओके, सो एरोमेटिक हाइड्रोकार्बन्स जो है वो हम का कंसेप्ट पूरा कर चुके हैं। तो आज हम उसके रिलेटेड एमसीक्यूज करेंगे, जिससे आपका इन डेप्थ स्टडी भी हो जाएगी और लेवल 1 के एमसीक्यूज है ये। फर्स्ट क्वेश्चन इज द स्ट्रक्चर ऑफ बेंजीन वाज प्रपोज्ड बाय, यस बेटा, हु प्रपोज्ड द स्ट्रक्चर ऑफ बेंजीन? तो कीप इन माइंड कि जो स्ट्रक्चर ऑफ बेंजीन है वो आपने दो स्ट्रक्चर करे होंगे अपने क्लास में भी, कि केकुले ने स्ट्रक्चर ऑफ बेंजीन, कौन कौन से स्ट्रक्चर थे वो? ये दो स्ट्रक्चर जो हैं दे आर प्रपोज्ड बाय केकुले। इनको केकुले स्ट्रक्चर भी बोलते हैं, इन दोनों को, जिसमें सिर्फ डबल बॉन्ड की पोजीशन चेंज होती है, राइट? So compared with aliphatic hydrocarbons, the number of hydrogens in aromatic hydrocarbons is, yes beta, number of hydrogen atoms जो होते हैं aromatic hydrocarbon, it is less than aliphatic, more than aliphatic, equal to aliphatic, or less or more, maybe any one. Just tell me. Aliphatic जी, come again beta, hydrogens in aromatic hydrocarbons. So see, if you have benzene, so benzene is aromatic hydrocarbon, and hexane, it is aliphatic. This is aromatic hydrocarbon. You know, aromatic hydrocarbon has high degree of unsaturation, but अगर हेक्सेन की बात करोगे तो उसमें अनसैचुरेशन कम होगी और उसमें नंबर ऑफ जो हाइड्रोजन्स हैं दे आर मोर। तो इसने पूछा है कंपेयर्ड विद एलिफेटिक हाइड्रोकार्बन्स, नंबर ऑफ हाइड्रोजन्स इन एरोमेटिक हाइड्रोकार्बन इज। तो एरोमेटिक हाइड्रोकार्बन में नंबर ऑफ हाइड्रोजन्स क्या होंगे? लेस देन द एलिफेटिक। मतलब एरोमेटिक हाइड्रोकार्बन में हाइड्रोजन्स का पूछा है ना, तो ऑब्वियसली नंबर ऑफ हाइड्रोजन एटम्स जो हैं वो क्या होंगे? कम होंगे ना। ओके, एम आई राइट? ओके, same example is given. C6H6 is aromatic, that is benzene, and C6H14, that is aliphatic. Now next, carbon carbon bond lengths in benzene. Yes beta, carbon carbon bond lengths in benzene, which one is the right option? So say, you know, in case of alkanes, you know, there are carbon carbon single bonds and bond length is 1.54 angstrom, or in terms of picometer it is 1.154 picometer, right? And in case of carbon carbon double bond, that is in alkene, it is 1.34 angstrom, or we can say 134 picometer. And carbon carbon triple bond, that is 1.20 angstrom, that is 120 picometer. And in benzene, there is partial double bond character. Okay, therefore it is 1.39 angstrom only. Means it is in between single and double bond. 139 picometer. That means option 3 is correct, because due to resonance, bond length in benzene lies in between 1.34 angstrom and 1.54 angstrom. Yes, beta. Okay, so it is 1.39 angstrom. That is option 3 is correct. Now, carbon-carbon bonds in benzene are, yes, beta. Carbon-carbon bonds, they are sp3, sp2, 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 and pi pp bond, or only pi pp bond. What is the hybridization of each carbon in benzene? Yes, so each carbon in benzene is sp2 hybridized. So there is sp2 sp2 bond, and at the same time there are pi bonds, 3 pi bonds on alternate position. It may be like this. So in this way, option number 3 is correct, because all the carbons in benzene are sp2 hybridized, and there are 3 pi bonds, and that pi bond is formed by p orbitals, unhybridized p orbitals on each carbon. Now 6 carbon atoms of benzene are of, yes beta, they are of 1 type or 2 types, 3 types or 4 types. It means all the carbon atoms of benzene are of same type or different type. So keep in mind all the carbons, are sp2 hybridized, and they are of same type. All are of same type. There is no difference between one carbon from the other, because there is delocalization of pi electron cloud. It is not like this, or this. These are the resonating structures, but actually structure is like this. This is called resonance hybrid. Four n plus 2 pi electrons represent the following rule. Which rule is represented by the 4n plus 2 pi? So 4n plus 2 pi electrons represent the Huckel's rule. According to this rule, molecule which is planar, first it should be cyclic, then planar, it should have conjugated pi electrons, and number of pi electrons should be equal to 4n plus 2. So such compound is aromatic, and that is called Huckel's rule or 4n plus 2 pi electron rule. Shape of the benzene is hexagonal planar. See, cyclohexane we write like this, but it is not planar, keep in mind, because cyclohexane has chair and board form and different other forms. Main is chair and board form. So they are non-planar. Cyclohexane is non-planar because in cyclohexane each carbon is sp3 hybridized, but in benzene each carbon is sp2 hybridized. That's why it is hexagonal planar. But cyclohexane we write like this, but its structure is not like this. It exists in chair and board form or other forms like half chair form, twist board form. There are different forms of cyclohexane. Okay, cyclohexane is non-planar, but benzene is hexagonal planar. Hybridization of each carbon in the benzene is we have done it. What is the hybridization of each carbon in the benzene? It is sp2. Each carbon in benzene is sp2 hybridized. If we talk about general formula of the benzene, so what is the general formula of benzene? So say if there is no ring in between, see this ring means delocalization of pi electrons. Okay, if we remove this ring, okay, then it becomes cyclohexane. Okay, then it becomes cyclohexane, and it is non-planar. This one is planar. Okay, general formula is, see, benzene is C6H6, right? And it is C6H14. So it is CnH2n minus 6. And it becomes C6H12 minus 6 means C6H6. The general formula of benzene is CnH2n minus 6. The total number of pi electrons present in the benzene are 2, 6, 4, 14. Yes, beta. Which one is the right option? Total number of pi electrons in the benzene. Yes, each carbon has one electron, unshared one electron, and that's why all the 6 electrons are delocalized. So total number of pi electrons are 6. So there are 3 pi bonds and therefore 6 pi electrons. Now this is about aromatic hydrocarbon structure. Now preparation. So formation of benzene from acetylene, how do we get it? By trimerization, tetramerization, dimerization or condensation? Yes, fast. So beta, in the formation of acetylene, it is like this. 3 acetylene molecules when passed through red hot iron tube at 873 Kelvin temperature, then there is a formation of benzene. CH, 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 CH double bond, CH, CH again double bond, CH, CH double bond. So in this way, there are three acetylene molecules which are involved in cyclization. That's why it is called trimerization, because three acetylene molecules are involved. So three molecules of acetylenes are involved in the reaction, and that's why it is called trimerization. If four are involved, then we call it as tetramerization. If only two are involved, we call it as dimerization. And if with the addition of the molecules, a small molecule is removed, when two molecules are added, a small molecule is removed, that is called condensation. Preparation of benzene from phenol. See, first is preparation of benzene from acetylene. This is the trick. See, this is the MCQ as well as the chemical reaction for the preparation of benzene. Now, from the phenol, how do we get benzene? See, this is phenol. Phenol is when OH is attached on the benzene. So, phenol to benzene. Yes, beta. But which type of reaction is taking place? Is it reduction, oxidation, addition, or dehydrogenation? Yes, beta. Obviously, say yes, yes, beta. It is reduction because there is a removal of oxygen. In this reaction, there is a removal of oxygen. If we write its structure, it is C6H5OH. Okay, so what would we get? C6H6. So overall, oxygen is removed. So removal of oxygen is called reduction. That is the classical definition of oxidation and reduction. And obviously some reducing agent should be used. So zinc dust is used as a reducing agent. Keep in mind, from phenol we get benzene by using zinc dust. See, two methods of preparation we have done. From acetylene by trimerization in the presence of red hot iron tube at 873 Kelvin, and second is from phenol by the reduction with some reducing agent, and this zinc is here acting as reducing agent. Now next is sodium benzoate gives benzene in the presence of, yes beta, out of these sodium benzoate that gives benzene in the presence of, this is sodium benzoate, this is benzoic acid. If hydrogen is removed, yes beta, if hydrogen is removed, then it becomes sodium benzoate. Now sodium benzoate to benzene means there is a removal of COONA. This reaction is called decarboxylation because carboxylate group is removed. So it is actually soda lime beta. is it is soda lime, and we get sodium carbonate. What is the role of calcium oxide here? It is acting as a drying agent. This drying agent, it keeps the mixture dry. Okay, then sodium benzoate and sodium hydroxide, on heating, sodium carbonate is removed and we get benzene. This is called decarboxylation reaction, and this whole mixture is called soda lime. This whole mixture is sodium hydroxide and calcium oxide as a whole, that is called soda lime. Okay, this is the reaction. Sodium benzoate with soda lime means sodium hydroxide and calcium oxide. We get benzene along with sodium carbonate. Benzoic acid gives benzene on being heated with X. Phenol gives benzene on being heated with Y. So, what is X and Y? Very easy question we have done just now. Tell me. See, benzoic acid gives benzene on being heated with X, and phenol gives benzene on being heated with Y. So, what is X and what is Y? Which option is correct? 1, 2, 3, 4. Which option is correct? So, benzoic acid gives benzene. See, benzoic acid means when benzoic acid react with sodium hydroxide. First of all, this is acid-base reaction and we get sodium benzoate. So obviously from sodium benzoate to give benzene, it is decarboxylation and we use soda lime. And second is phenol to benzene. Just now we have done in the presence of reducing agent, that is zinc dust. So option number 4 is correct. See, benzoic acid with sodium hydroxide gives sodium benzoate, and sodium benzoate with sodium hydroxide and calcium oxide give benzene and sodium carbonate, and phenol with zinc dust gives benzene and zinc oxide. That's it. So option 4 is correct. Got it? Any doubt? Now next, properties. So these are the methods of preparation. First is from acetylene, second is from phenol, and third is from sodium benzoate. Next, which of the following is the strongest ortho-para directing group? OH, Cl, OCH3, CH3. Which of the following is the strongest ortho-para directing group? Strongest 1, 2, 3, 4. Yes, beta. It is 1. Very good, because in OH, chlorine, OCH3, CH3, all of them are activating groups. First and foremost thing is all are activating groups. Why? No, not all, except two. All are activating groups. except chlorine, because in chlorine, though it is ortho-para directing, due to plus R effect it is ortho-para directing, but due to minus I effect it is deactivating. Chlorine, it is odd one out. Chlorine is deactivating group because of more electronegativity. Chlorine has minus I effect and it is deactivating. Okay. At the same time it is ortho-para directing. Because of plus R effect. Now come to OH. It has plus R effect as well as minus I, but plus R is dominating group. So it is activating as well as ortho-para directing. Same is OCH3, it is plus R minus I. Now how do we know it is plus R, it is minus I? Yes, beta. So minus I is because of electronegativity. Oxygen is more electronegative than carbon. Chlorine is more electronegative than carbon. That's why these are having minus I effect. But chlorine means all halogens. They are at the end of the series. That's why their inductive effect is dominating while deciding the reactivity. That's why halogens are deactivating groups, because reactivity of halogens is decided by inductive effect and orientation by resonance. Now what about CH3? It has hyperconjugation. In some books it is written as it is also plus R, but actually it shows hyperconjugation, and that's why it is ortho-para directing and activating. It has plus I effect as well as hyperconjugation, and both are electron releasing effects. Both are electron releasing effects. But plus R is dominating over hyperconjugation and plus I. So we left with 1 and 3. Now out of 1 and 3, in OH there is no steric hindrance because only hydrogen is attached to oxygen. But in third, methyl is attached to oxygen. Due to steric hindrance, its resonance is less. Keep in mind, resonance is inversely proportional to steric hindrance. Resonance is inversely proportional to steric hindrance. That's why first one is strongest ortho-para directing group. Okay, see the explanation. NH2, NH, R, NR2, OH. This is the ortho-para directing influence. Okay, and strength increases. So OH group of strong activating ortho-para directing group. These are the few statements regarding benzene. So identify the correct statements. Benzene is an aromatic compound. Is it true or false? Yes, benzene is aromatic. Okay, that's true. Second is, a molecule of benzene contains 6 delocalized pi electrons. What about this? It's true because I told you earlier that in benzene there are 6 pi electrons, and these pi electrons are delocalized. Next, in benzene, each pi electron belongs to only one carbon atom. Wrong statement, because all the 6 pi electrons of each carbon, 6 p electrons of each carbon, they are delocalized. Benzene gives fission products on during ozonolysis. That's true, because I write the reaction. See, this is benzene. So 3 molecules of ozone are added in it. When we add them, it becomes like this. Single bonds will not break, but double bonds, in double bonds there is addition of ozone. It is like this. Benzene triozonide is formed, and then there is a fission in the presence of zinc H2O. So we get CH, CH, double bond or double bond. Glyoxal is formed. 3 molecules of glyoxal we will get. That means A, B, C, they are the correct. A, B, sorry, and D. C option is incorrect. A, B, and D are correct. Two structures of benzene proposed by Kekulé differ in. Yes, beta. Two structures of benzene which are proposed by Kekulé, they differ in. They differ in the position of the double bond, because these are the Kekulé structures. So double bonds occupy the different positions. The function of anhydrous AlCl3 in the Friedel-Crafts reaction. What is the function of anhydrous AlCl3 in Friedel-Crafts reaction? So beta, you know, Friedel-Crafts reaction is, this is the benzene ring. Benzene will react with methyl chloride, means alkyl chloride, in the presence of anhydrous AlCl3 to give toluene from benzene. So what is the role of anhydrous AlCl3? You know, AlCl3 is acting as Lewis acid. It will take away Cl negative. We get CH3 positive along with AlCl4 negative, and it is electrophile. So that means, what is the role of anhydrous AlCl3? To produce electrophile. This is Friedel-Crafts alkylation. Now Friedel-Crafts acylation. in Friedel-Crafts acylation, benzene react with acetyl chloride, again in the presence of anhydrous AlCl3, to give this product, that is acetophenone. Role is same. It will take away this Cl negative and we will get CH3CO as the electrophile. Okay. Okay. C2H2 red hot metal tube, that is iron tube, we can say, to give A, and then fuming H2SO4 to give B. So what is B? Yes, beta. What are the products? What is the product B? First tell me what is A. Yes, C2H2 means acetylene. So acetylene in the presence of red hot iron tube, there is triation. In the presence of red hot iron tube, so we get benzene as the product. So A is benzene. You can write like this. So A is benzene. Now fuming H2SO4. So you know H2SO4, fuming H2SO4, that will do the sulfonation and we get the product as benzene sulfonic acid. So see, red hot iron tube, we get benzene, then in fuming H2SO4, by mistake it is fuming H2SO4, we get benzene sulfonic acid. So which of the reactions are given undergone by the benzene? Which type of reaction? So beta, electrophilic substitution reactions. It undergoes electrophilic substitution reactions because in order to retain aromaticity. To retain aromaticity, it undergoes electrophilic substitution reaction, not addition reactions. These are easily undergone by benzene because if they undergo electrophilic substitution reactions, then their aromaticity is retained, and you know aromatic compounds are stable. Overall, aromatic compounds are electron rich. So as they are electron rich, so electrophile is attracted towards them. Electrophile is attracted towards them. Okay, and if electrophile is added, then its aromaticity is destroyed. So that is difficult to take place, but electrophilic substitution reactions can be easily undergone by benzene because by doing that it retains its aromatic character. Which of the following reactions is useful to convert benzene into toluene? Just now we have done. So which of the following reaction is useful to convert benzene into toluene? This is benzene. To convert benzene into toluene, which reaction? Friedel-Crafts alkylation, because methyl chloride in the presence of anhydrous AlCl3. So benzene is converted into toluene. It is Friedel-Crafts alkylation. Calcium carbide react with water to give A, and red hot tube, when it pass through A, pass through red hot tube, we get B, and with the AlCl3 CH3Cl, we get C. In this sequence, B and C are. What is B and C? First tell me what is A. This is a big hint. Red tube hot, we can say red hot iron tube. I hope you understood. Yes, acetylene. A is acetylene because calcium carbide, calcium carbide is calcium 2 plus C2 2 negative. So water will give H plus and OH negative. So C2 2 negative and 2H plus will give C2H2. Calcium 2 plus and 2 OH negative will give calcium hydroxide. So acetylene is acetylene. When 3 molecules of acetylene are passed through red hot iron tube, then we get benzene, and this benzene, when treated with methyl chloride in the presence of anhydrous AlCl3, we get toluene. That means B is benzene and C is toluene. Which of the following is the most reactive towards ring nitration? Yes, out of these 4, benzene, it is this one. Acetylene, this is like 135 trimethyl benzene or symmetrical trimethyl benzene. This one is toluene. Acetylene is this one. Xylene, metaxylene, CH3, and at meta position one more CH3. So these are the compounds. So which one is the most reactive? Towards ring nitration. Nitration means, nitration, sulfonation, Friedel-Crafts alkylation, halogenations, Friedel-Crafts acylation, sulfonation, all of them are electrophilic substitution reaction. So, electrophilic substitution reaction increases as electron releasing groups increases. So see, in benzene there is no such electron releasing group. In acetylene there are 3 electron releasing groups. In toluene there is only 1 releasing group. In xylene there are 2 electron releasing groups. That's why. So tell me which one is the most reactive? Yes, it is the acetylene, because in this case there are 3 electron releasing groups. That's why this one is most reactive towards ring nitration. Which of the following will have the fastest rate of reaction with bromine and FeBr3? This is bromination, and bromination is again, you know, electrophilic substitution reaction. So here in benzene there is no releasing group because hydrogen is there. NO2 is, it has minus I and minus R effect, means it is electron withdrawing group. Methyl, hyperconjugation and plus I, it is electron releasing group. OCH3 plus R and minus I, again electron releasing group. Though due to inductive it is withdrawing, but resonance is dominating over inductive except in halogens. And if you see the effect, resonance effect is more than hyperconjugation, which in turn more than inductive. Tell me which one will have fastest rate of reaction. This is the best trick of the day. First you have to write their effects. It is most electron withdrawing, therefore electron density of the ring is least, therefore it is least reactive. So there is a competition between third and fourth, toluene and anisole, methoxybenzene. So methoxybenzene is also called toluene. Methyl benzene is called toluene. Can also be written as methyl benzene. This is methoxybenzene. Oxybenzene is also known as anisole. Okay. So tell me, just now I have written this. Resonance is dominating over hyperconjugation. This is electron releasing due to hyperconjugation. This is electron releasing due to resonance. That's why fourth one, plus M or plus R of methoxy group, that is dominating, and that's why methoxybenzene is, or anisole, is most reactive. If we write the order, fourth is more reactive than third, third is more reactive than first, and second is least, because nitro group is electron withdrawing group, which is deactivating. This is deactivating group, means it decreases the reactivity and it is less than that of benzene itself. Among the following compounds 1, 2, 3, the correct order of the reaction with electrophile. Yes, better. Among the following compounds 1, 2 and 3. See, this is methoxybenzene. This is OCH3 group. This is NO2 group. What is the nature of this methoxy group? Is it electron releasing or withdrawing? It is electron releasing group due to plus R effect. Minus I effect is of little influence. In case of benzene, there is no such group. NO2 has minus R as well as minus I effect. Overall, it is electron withdrawing group. So what is the order of reactivity? Which one is most reactive? 1, 2 or 3? One is most reactive because methoxy group is electron releasing group, so it increases the electron density on the benzene ring. And therefore electrophile will easily attack on it, readily attack. But NO2 being electron withdrawing, it decreases the electron density. On the benzene ring. So that is, as it decreases the electron density on the benzene ring, so attack of the electrophile is decreased or hindered. That's why first is most reactive, third is least reactive. So obviously second is in between. So it is first, second, and then third. So plus M of methoxy group, that is dominating, and that's why first is more reactive than second. It is done more reactive than third. In Friedel-Crafts alkylation, besides AlCl3, other reactants are yes beta. Friedel-Crafts alkylation में AlCl3 besides AlCl3, what are the other reactants? Benzene ring and methyl chloride. In the presence of anhydrous AlCl3, we get toluene. So it is C6H5 CH3 plus HCl. Which of the following will be most easily attacked by an electrophile? Yes, beta. Which of the following will be most easily attacked by an electrophile? Benzene, chlorobenzene, phenol, CH3. Toluene. You know, this chlorine has plus R and minus I effect. It is overall electron withdrawing group. OH3 plus R and minus I, overall electron leasing group. CH3 hyperconjugation and plus I, overall electron leasing group. In hydrogen, no effect. So if we compare, least reactive is second. There is a competition between third and fourth. So tell me which one will be most easily attacked by an electrophile? It should be third, because in third resonance is there. You know, resonance is dominating over hyperconjugation. Inductive is the end, at the end. First of all, there is resonance, then there is hyperconjugation, and then inductive effect. So we will look at the resonance first. Except in halogens. In halogens, reactivity is decided by, you can write a note. This is also a trick. In halogens, inductive effect, I effect, decides the reactivity. That's why overall it is electron withdrawing group. So plus M of OH group, that is dominating. In halogenation of aromatic compounds, catalyst is in halogenation. You know, benzene with halogen in the presence of FeX3 or AlX3, we will get halobenzene. So it is FeCl3 or a AlCl3. Both can be used. Any Lewis acid. Nitration mixture is nitration. Nitration mixture, or we can say nitrating mixture. It is 1:1 of concentrated nitric acid and concentrated sulfuric acid. This is the reaction. Sulfuric acid along with nitric acid. So we get nitrobenzene as the product. Thank you all.